Assignment 8 is going to be part 1 of 3 modeling strategies. We've been doing bottom-up modeling for the first part of the semester, and it consists of creating each part individually, bring them into assembly, applying the mates, and then creating the exploded view, creating the drawing. So for this project, we'll be creating each part, insert the part into the assembly, and then generate an exploded view. The drawings will be optional, but these 3 are pretty much our standard processes. So looking at the parts, we can generate a revolve. This will probably be just a regular extrude, and a regular extrude would look at doing the hole wizard for M24, and assuming that they're both, M24, and looks like they've put in the by 3 this time, so they've given us a pitch, and then the bolts have their designations on them. So let's go ahead and get started with some revolves. So we're still in metric. We're going to build the base. So front plane, sketch, and if we go into the S key, can do the center line, infinite length, and vertical. And I still find it just as easy to hit escape and then L on the keyboard. Since we're going to generate the M24 with the hole wizard, we'll close this off. If I was going to have that be part of this revolve, I would start off out in space somewhere and leave the hole away from the center line. So our diameter is, as soon as I find it, see the 100 millimeters for the outside, so about 40 to start. Overall height is 65, so we can get close. The wall thickness, back down and around, and close it off. We go into our dimensions, so we have the 65. The diameters then, once I pick the center line, it goes into the diametral, so radial, diametral, radial, diametral. If you pick your object line, you're not going to get the diametral. So you can put in the radial and keep going on with it if you need to. The inside diameter is 60. Since it's in that diametral mode, it will jump into it. And then our thickness is 20 on the bottom. And that looks pretty good. We got our geometry in there. So features revolve, and go ahead and accept. And then we have the hole pattern for the M8s and the through hole for the M24. So let's start with that. And S key, hole wizard. And if I go to Control 6 or normal to the bottom, that will rotate it around. ANSI metric. Not really worried about the bottoming tap or tapped hole. Haven't seen any major difference anyway. I think more of the blind holes that we'd be concerned with. M24 by 3 on our call out. So let's see, that was on the top and also in the bottom. So up to next, and if we do a thread class, this is going to the ANSI, but a standard metric would be the G values. So 5 or 6 G in our designation. And then position, we'll put it at the origin. Go ahead and accept. Control 7, go up to the top. And S key again, we're going to do the M8s. And I'm set not to rotate to sketch, or it's not doing it with the hole wizard anyway. So I'm hitting Control 5 to generate. And we're looking for an M8 by 1.25. And our depth will be 17 millimeters deep, so that sounds pretty good. So we need to switch to a blind in condition. And depth of 17. And then we have to decide if we're going to the drill tip or to the shoulder of the drill. So a millimeter is not really that much. Usually, as a machinist, I'm going to look at that and say I have plenty of material there. I'm going to drill it, at least a millimeter or two deeper. So the length of the thread is on the bolt that they've chosen is 30 millimeters. So it has to go through 13, and 3 is 16, and another 16 would put it right at having about 2 millimeters of clearance from the bottom anyway. 17 millimeters being kind of an oddball anyway. Maybe if we were going to go to actual thread depth, then it just determines on the hole call out, as the hole call out really defines this quite a bit better. So 19 millimeters, 17 millimeters for the thread engagement. Make sure we have plenty. And positions, and we'll rough locate the first. And we haven't really had a chance to do too much with our sketch patterns, and for that matter the feature patterns. So we'll take a look at both of those. The first then is I want a construction circle. So if I do the S key, or in this case the sketch entities, and go to circle, there's no circular center line or anything, so we draw the circle and go to for construction. We'll put our base circle diameter on of 75 millimeters. I'm going to make sure that I have the orientation set by selecting and control selecting the vertical to the origin. And when I pick this this point and go up to the sketch and pick the linear sketch pattern pull down, circular sketch pattern, we're going to have a total of 7, 8. So we're going to have 8 equally spaced, and we're going to, don't need to dimension the radius, but could possibly do the angular spacing. In this case, it's probably easier just to go ahead and accept it. Thing to keep in mind, and it is not readily apparent until you get to the drawing, and it says there are 9 hole positions. When you do the circular, it puts a point, or at least it used to put a point, at the center, and maybe it doesn't anymore, so we'll have to check it when we get over to the drawing. But if it shows up with 9, it's because there's a point at the center. Alright, so getting this to go fully defined, if I grab one of the points, drag it away, bring it back, then that will usually get it to go fully defined. If it doesn't, grab one more and bring it back until it goes coincident, and allow it to pick up its geometry. Alright, so I mentioned the feature pattern, so I'm going to suppress that out just so that we can review. S key, hole wizard, all of our previous items should stay the same, so it bumped it up a little bit. Alright, I'm okay with that. Go to positions, If we want to do this without a base circle, then I can set to vertical. Our radius is 37.5 and accept it. We need a axis of revolution, so on the feature, we go to the circular pattern. If I pick the cylinder, or I can turn let's see, where is that? Turn the temporary axes on, then we can pick the temporary axis. And again, there's going to be a total of 8 of those. And the spacing, everything else should look good. So if I do the preview, see if I highlight, maybe since that's, okay, so since I can still highlight even though it's suppressed, I can see that they're pretty much the same thing. You just have to decide which one is a little more convenient for you. So let's go ahead and save. And I don't think I created my folders for the project, so new folder, assignment 8. And this is going to be the base chamber. And it gives us that it is made out of steel. So we'll go ahead and, I guess go ahead and close that. New part, grabbing the part millimeter, and these will go pretty quick, mainly because of the geometry. Now, design intent says that when I bring this in, the orientation to the base chamber top plane would be a good spot to start this sketch. So S key and circle, and we bring those back. So we have 60 on the interior and 100 on the exterior. And then we have to make the same type of choice if we want to use the hole wizard. The nice thing about the hole wizard going through is it has a little more information on the callout. Oh, and I jumped out of it, so let's go ahead and use the S key and extrude. And because it thinks that I wanted a body or a contour and region for the body, I will clear out the selected contours. And then this is a 3mm thick gasket. So go ahead and accept. Opening up, after I said I wanted to do the hole wizard, select the face so I don't get the 3D sketch. Regular hole. This is an ANSI metric clearance, so we're just going to go to drill sizes, and we're given, okay, we're not given, so 10mm for the, actually calls out 10mm for 16 holes, 8 in the cover plate and 8 in the gasket, so we will scroll down to 10. And for an 8mm bolt, that is plenty of clearance. So the translation at 8mm works out to about 315. A standard clearance hole really wouldn't be more than a millimeter, 354, yeah, 354, 355, whatever it is, would be quite a bit of clearance. Typically 323 to about 330, so 8.1, 8.2 would be plenty of clearance for most positional. And up to next for clearances, position. I still like the base circle, so S key, circle, bring that out until we find the coincident. Go for construction, right click, select, vertical. We said that that is 75. Since we're in here, we'll stay with the circular sketch pattern of 8. Tab to look at the preview, and then drag one out and back. Oh, that probably was the reason the other one is I ended up at a quadrant. So if I check that relation on the base, I might see that it inferred another relation. So this one is going to be our gasket. I'll go ahead and close that. Now, the other thing that we've done previously, before I closed that, I should have looked at, since the clearance holes are good, that this might be one of those places that I can reuse this geometry and save some time. So save as, copy and open, and we can change this over to the cover plate. All right, and the reason we want this to open is so that we can immediately start editing it. And if it asks us to keep the original document open or close the original document, doesn't really matter. If I was prepping for the assembly, I'd probably keep it open. All right, so the changes that we want to make is I can leave the 60 millimeters, just change it to the circle to a construction. Its thickness goes from 3. All right, so just double clicking on the part gives me the thickness, and I can change it. And I've never adopted the habit of rebuilding from the modify box, but keep in mind you can regenerate, rebuild from modify. You can come up and rebuild, and you can also hit the Control B, Control Q, or Control Q on the keyboard. So then we're to the S key. The whole wizard goes back to the M24. So we scroll down, maybe not that much. M24 by 3 up to next is fine. No real tolerances. The position goes to the origin. Accept. And save to the cover plate. Alright, so that gives us our 3 components. The fasteners we will pull out of the toolbox, or we will go to a website like McMaster and download a threaded fastener for our assembly.